Alrighty, Gatekeeper here. I'm going to show you how to build a keying circuit. This is for a Pacific person. I might just leave this video public, maybe. Might help somebody with a repair or something. So we're putting together a two SD1446 DEI 2 transistor ampere. And it's time to put a keying circuit on here. Alright, here's our components to the keying circuit. We have the keying transistor. We have the electrolytic to keep the relay from chattering, and it also is used for smoothing the DC signal once it's converted from AC to DC. We have our diode. We have our cap. Here is the first schematic I ever drew for me to use for reference on building a keying circuit. I drew that about 5-6 years ago. I eventually got to where I didn't need to use it no more. Alright, really quick, to let you know what a keying circuit does. Alright, a keying circuit, the relay, when you turn your amplifier on, it sends a positive DC signal to your relay. But the problem is the relay does not have a negative signal, so the relay will not actuate until it has a negative from the board to complete the circuit to energize the coil of the relay for it to actuate. So here's how we do that, because we want that to happen when we key our microphone, or when we key our microphone in audio for sideband usage, which we won't get into right now. How this is done is first by a 10 to 22 picofarad ceramic or silver dip mica cap. I usually use ceramics. This is a 10 picofarad ceramic cap. I know it's not focusing in, but what happens is your RF flows through this cap in series. Your RF signal flows through this cap. And what it's doing with only being a 10 picofarad cap is only taking a small sample of that RF. Just a very small sample. Okay. It flows through this diode and converts that AC RF signal into a pulsating DC signal. Then this filter cap electrolytic filters that into a proper DC voltage. Then what happens with that DC voltage? This transistor is just being used as a switch in this process. This is being used just as a simple on and off switch. One side of this transistor is touching the ground of the board. The other side of the transistor is touching the negative part of the relay. And then the middle of it, which is the base, which is where the electrolytic and the diode is hooked up to, that DC voltage goes through this base, turning this transistor on. And once this transistor is turned on, all it does is connect the left leg to the right leg, just like a switch. Just imagine this as a switch. Let me go ahead and get it. Put the phone down here. I'm going to go ahead and get this vent the way I'm going to need it vent. Might not be the prettiest key and circuit since we're gonna be doing it like this on the phone here. Alrighty. Alright, sorry about that. So look at this transistor as a switch. The left leg is connected to the ground of the board, which is your emitter. The right leg is touching the relay, the negative of the relay. We want, when we key the mic, we want a ground to connect to that relay. So as this transistor is sitting right now, the left leg and the right leg is not touching. They are not physically touching. You have to turn this transistor on. You have to give this transistor 0.7 volts or more to make this transistor turn on. And once this transistor is turned on, the left leg will touch the right leg. And what does that do? It connects a ground to the relay. I know it probably took me a year and a half, 2 years to even understand that. So this, like I said, this cap is doing one and two things. It's actually using the filter, the pulsating DC, which therefore keeps the relay keyed without it chattering. That's why a relay chatters without this, or unless it's a different style keying circuit, is because the DC signal is pulsating. That's why it's chattering. All right, let's go ahead and build this sucker. At first, we want to get your transistor with the front facing like this. Get it in that orientation. Left leg that way, right leg that way, in the middle leg down just like that. All right. Get our electrolytic and go ahead and spread the electrolytic out. All right. Now have the electrolytic spread out just like this. Notice the negative part of the electrolytic. The negative part of the electrolytic is going to be connecting to the emitter part of the transistor. See if we can get this focused in here. There we go. You can see emitter base collector. So we're going to wrap this around just in this orientation, just like this. See the negative? It's going to wrap around this lead. Positive side is going to wrap around this lead. Like so. Flat part there. Negative part, electrolytic to the left lead. Positive part to the right lead. Now we're looking at this. Next is to connect the diode. The diode, you want the striped to connect to the base, which is the cathode. You want the anode to connect to the emitter. So it's going to connect diagonally. As you see, the stripe is right here where my finger is. The stripe is to the right. It's going to connect diagonally just like this. Just like that, diagonally. Well, as you see if we can get that to focus in, the glass diode is hooked up diagonally, with the cathode hooked up to the base, which is the middle, with the anode hooked up to the emitter, which is the left. The only thing that's going to hook to the right leg is going to be the positive of the electrolytic capacitor. Alrighty. Next is going to be our RF sampling capacitor. The capacitor which will be hooked up to the incoming RF, which is going to take a sample of the RF, so we can use that sample to convert it into a DC voltage to bias this transistor on to connect the ground plane of this board, which is your negative, to the relay. So that relay can actuate and then carry the RF on through this piece of coax here on out into the input circuit. One leg connects to the base, other leg connects to the incoming RF. Like so. And there we have our keying circuit. Go ahead and solder your connections. Trim off the excess on the base, which I will show you. Solder the left side, this side right here, to ground. Solder the right side to the negative part of your relay, the negative side of your relay that you'll be using for the negative. And you solder this end of the blue 10 picofarad cap to the incoming RF. You can either solder it to the input SO239 connector on the case, or like the way that I tend to do it now, to be a little bit more neat, is solder it to the input where the input RF is going into the relay, which tends to make things a little neater. Shorter connection. Alrighty, let's get it soldered up. Alrighty, when soldering, I suggest you leave your soldering iron anywhere from 500 to 680 degrees. I'm a little bit more than that, but we are soldering sensitive components. The transistor and the diode are somewhat sensitive components. Get in and get out quick. Go ahead and tin the lead of the capacitor for the incoming RF. It's a good idea to always tin every connection. Whenever you're about to solder anything, it is always a very good idea to tin it up first. The only time I do not tin my connection is when it's something I will be soldering to the board, because I will tin it while I'm soldering it to the board. For example, these capacitors right here, 10 ohm resistors right here. Now I always tin these. I always tin these before I solder them to the board. so I won't have to press down on the soldering iron. But anything like that, I usually like soldering bigger, tinning bigger leads, but just small leads like that, you don't have to worry about tinning them, because I actually tin them while I'm soldering them to the board. It's a good habit to begin tinning everything so you will not have any cold solder joints. Alrighty. Let's cut off the excess wire. So there you have it. All soldered up, ready to be installed. Don't forget, negative side is the left side to the board. Right side to the negative side of the relay. This goes to your incoming RF. Let's go ahead and install it. Alrighty, we're ready to solder. Negative to the board. I need to get in and get out real quick somewhere. I'll scrape the board a little bit, get some of that so that solder run a little quicker. Alright, I will be soldering right here. Right here. I'll be soldering this side of the cap that's sticking up right here, the blue cap that's going to be getting our sampler of our signal to this lead of the relay right here, because this lead of the relay is where the input RF will be coming into the relay. We wanted to take the sample of that RF when you key that microphone, send it through here and do its thing, connect this ground to the relay. All right, there's the finished product. Trim off any excess. One thing also, I did not get it all with my first build. Since my first build consists more of glue than solder. I call it the epoxy one pill. I'm sure you know this, just in case. Always heat the object up that you are trying to solder. Always heat the object up that you are trying to solder. This right here is just a transmit LED, by the way, to light the inside of the box up blue. I had to say that keying circuit turned out pretty nice. It's actually one of my better ones. One of my better ones. Like I said, trim out any excess that you have. Like I could get right there and trim that little piece off right there if I wanted to. Blue cap is hooked up to this side of the relay, which is where the incoming RF is going to connect to. Negative part's going to the board, which is ground. Positive part, which was to the right side of it, is going to the negative part of the relay. And as you see this diode on this relay, you see how the stripe is to the right. That's where the positive will be hooking up. Positive will be hooking up from the switch. Remember, I always said the stripe faces towards the positive on the diode. That diode is there to shunt any static electricity built up by the coil to ground. So there you go, a successful keying circuit. Very nice one, actually. I hope this helped. One last thing. Sideband delay. Usually use 1,000 microfarad electrolytic. Usually works really well. 1,000 microfarad electrolytic. If you wanted an automatic sideband, you would basically just hook this up in the same orientation that electrolytic is already hooked up at, meaning you would put the negative side of this cap to ground, the positive side of this cap to the negative part of the relay, which I could go ahead and do that and get that out of the way. But I'm probably going to be I'm going to wait and put this on last before I get everything. The wires ran from the SO239s. I probably will be sitting at something like, probably something like over here on the side. Cut this lead shorter, solder to ground. Extend this right here and run a wire from here to the side of the relay. That would be automatic sideband. If you like to put it on the switch, you can put this up close to the switch or wherever you like. Solder negative side of the board just like we talked about. Run that to the switch. Then run a wire from the switch to the negative side of the relay. There's your delay cap from sideband. SSB. Of course, that will be Class C since this is a Class C right here. And the AB biasing, it's the same deal. Same deal. That's the delay cap. So that this amp will not key up and chatter when you're on sideband until you start talking. Well, hope this helped. Gatekeeper said it. On to the next.